Hey, welcome to ellipse equation writing. Pretty simple, given some information. Vertices, foci, minor axis, major axis. Well, hey, you need to know a couple things. Let's take a peek up here. Well, hey, we need A. A is going to be the measure of the distance along the major axis, vertex to center to vertex. And B is the minor axis, talking about the co-vertices to get to that. So looking at this first problem here, vertices are 4 comma 2, negative 2 comma 2. We got a minor axis that's 4 units long. You are just flat out crazy if you do not draw the information given. So let's get a little XY axis going here. And let's see what we got. All right, well, for starters, given in the information 4 comma 2. So we're going to go 1, 2, 3, 4, comma 2. I like labeling those guys and pull a V for vertex just to remind me that's what I got right there. Also looking at a negative 2 comma 2. Right about there. Put another little V for vertex. So notice in the problem it didn't tell us the center, and we are going to need that to write the equation. So center, understood to be, kind of makes sense, halfway between the vertices if we're going to draw an ellipse. So the center literally has the coordinates of 1 comma 2. Go ahead and throw that on there. So right now I could at least start writing the equation if I wanted to. So if I know the x coordinate is 1, I can change the sign, write myself an x minus 1 squared. Over top of something, not sure what the something is yet. A plus sign, and then over here on the other side, I know my y coordinate is 2, so I'm going to switch the sign there. I get a y minus 2 squared. And all ellipse equations are set equal to 1. So the question is, what's A and what's B? We know that, and we got it. Well, if you take a look at what's drawn here so far, we'll go ahead and do the minor axis. So if the minor axis is 4 units long, well, the vertices make up the major axis. So we already know that's going to go horizontally. So if I could just go ahead and squeeze 2 units to the north and 2 units to the south, that's a total of 4, distance of 4, and that's the minor axis. So I could go ahead and draw the ellipse in here if I wanted to. And we'll just go ahead and do that just for kicks. So looking a little something like that. But more importantly, we have to know the distances from the center of the vertices. Well, since this is the major axis or longer one, and it's literally a distance of 3. So I know that since my ellipse is sort of a football on its side or extended horizontally, then I know the bigger number, or a squared, is going to go underneath here. And I know the smaller number, or b squared, is going to go over here. Well, the short way, can't really squeeze it into my drawing, but I'll put a little arrow. So the distance from the center up to the co-vertices is 2. So we know that distance is 2. We know the longer distance is 3. So all I have to do is come over here and fill those in. So I'm going to go ahead and grab the eraser. I'll get rid of that guy. And I'll get rid of that guy. And I'm going to say, well, hey, if a is 3, then a squared is 9. And if b is 2, then b squared is 4. And we got it. So get another little example down here. Let's take a look at the second one. Again, you're crazy if you don't take the time to draw it. So let's get a little x-axis going here. Let's get a little y-axis going here. Give myself a little extra room there on the left. And let's get some points on here. So negative 6 comma 3. Right about there. Okay, and that's my center. I'm going to put a C for center. 1 comma 3. That's a vertex. So I'm going to put a V right here. So hey, we can go ahead and count this up right now. So if I were to count the distance from the center over to the vertex, well, that's a distance of 7. So I already know A equals 7. So we can start writing this equation up if we want. Well, so I know the center is negative 6, comma 3, so my x-coordinate, I'm going to switch the sign. I got a x plus 6 there. And my y-coordinate's positive 3, I'm going to switch the sign. I got a y minus 3 working there. And again, we know it's equal to 1. So same situation as the last one. This guy's stretching horizontally, so I know the bigger number is going to go here, and I know the smaller number is going to go here. Well, hey, a equals 7. I already got that guy. So I'm going to jump right here, and I'm going to say, hey, if a is 7, a squared is 49. So the question is, what's b? Well, tangent. Now, what's that mean? Tangent to the x-axis. So it means it's going to skim or touch the x-axis. And a lot of times people don't realize that a tangent area compared to the center has to form a right angle right there. So we could draw the ellipse in here if we want, take a shot at it. And it's going to be a big old long ellipse. But the point is, it's going to touch right down here on the x-axis, or skim it. So same deal, you can count the distance down, and literally 1, 2, 3 units down. So I know b is 3. Well, if b is 3, I need a b squared over there underneath. So I got a 9. And we have standard ellipse equation. Hey, thanks.